Working with rational exponent mean we have to work with the root as well. It depends what is the root it is. Let's suppose here the root is nth root. We can see it's b nth root. So how do we write it in a fractional form or in an exponential form? We just write b as it is, the variable, and the nth root we have to write it in a fractional form. So we have to write it like b to the power 1 by n. Let's suppose we have something other than this one, like we have b whose nth root is there, but here inside the b there is some nth power all as well. So how are we gonna write it? We're gonna write b 1 1 by n as it is, like we have done in the previous this question. But because you can see here is an n m here, this thing, so we have to put it here as well. Now if I open the bracket, you know that m times 1 is m over n, so it will be written like this. Let's suppose we have seen another example which is of some number rather than some variable. I have some 8 to the power square and its cube root of 8 to the power square. This 3 outside the root means it's a cube root, so don't confuse it with some other number. So how do we have to write it? First of all, I'm going to write my constant, which is 8 as it is. Now I'm going to write my square, which is inside my constant. I'm going to write it as it is. Now I have to write my cube root. So whenever I have to convert my cube root, I have to write it like this 1 over 3 in a fractional form. Now I'm going to open my bracket and I'm going to write like this 2 times 1 by 3, or you can write directly like this 2 over 3. It's up to you. Further, if I want to solve it, because this is an exponential form, and if I want to solve it, I always have to see what's in the denominator of a constant. I can see it's 3 in the denominator of the constant power. So I have to think of a number. When I multiply it, its power become 3. So I know that actually 2 times 2 times 2 is equal to 8. Or I can also write like this, 2 power cube is equal to 8. So can I just replace it with 2 power cube? Yes, I can. So I just simply replacing my 8 with 2 power cube, and I know that this 8 has 2 by 3 as well. So I'm going to put 2 by 3 as it is. Now if I open my bracket, I know my rule that it's going to multiply with it. So 3 times 2 is 6 and it's divided by 3. So either you can do like this or you can just simply cancel here. I'm preferring canceling because I know it's very easy. So I'm left with 2 power 2, which is actually equals to 4. So see how this is a very simple thing. Let's see some more examples like this one. For instance, I have a question which says 81 to the power 3 by 4. This time I don't have a radical. This time I only have some fractional form. So I have to think of a number. If I multiply it 4 times, I get that 81. Why 4 times? Because I can see here in my power, my denominator is 4. So always see the denominator what it is. Here I have 4 in my denominator. So I have to think of a number. If I multiply it 4 times, not with 4, I have to multiply it with 4 times. I get 81. So in my mind, I got a number and it says it's 3, because I know 3 times 3 times 3 times 3 is actually equals to 81. And I can also write it like this, 3 power 4 is equal to 81. Or we can call it 3 exponential 4 is equal to 81. So I'm just going to simply replace it here with 3 power 4, and outside power will remain as it is. I just simply substitute my value of 81 instead of 3 power 4. So now I'm going to open my bracket, and I know that this bracket means that I have to multiply it with, and now I have to multiply 4 times 3 is 12 over 4. Remember one thing, don't multiply this 4 with the denominator. It's only have to multiply with the numerator. It's not going to multiply with the denominator, because if it's only written 4, it means that it's simple 4. It's in the numerator thing. It's not in a denominator thing. So keep this thing in your mind. Simply multiply 4 with 3, you will get 12 and divided by 4. If I simplify this thing further, 4 times 3 is 12, so it's 3 by 1, or I can write 3 power 3. which is equals to 27.